Objective 1, graphing polynomial functions. We're going to graph polynomial functions in factored form. For instance, x squared, x minus 2, x minus 3 cubed. Later on in the chapter, we'll talk about factoring these higher degree polynomials. Some can be factored, some can't. And to begin with, if we have a factor of x minus c, that's to the first power, we know how the graph goes through the x-axis. At x equals c, we have a 0. It just goes right through. If we have a factor of x minus c squared, it looks like a parabola locally, right at c. Could be above, could be below, just all depends on what happened before or after that 0. And if we have x minus c cubed, well, it does this twisty-turny thing. This is what's called an inflection point in calculus. Here the concave side is down, here the concave side is up. The concavity changed right at x equals c. So we're going to use that information to graph a polynomial such as this. First of all, we're going to make a Cartesian coordinate system. And we're going to draw a rough graph without putting a scale on the y-axis. We're really interested in these basic concepts together with the shape of the graph. If we want a more precise graph, we can use a piece of graph paper and accomplish that. Well, first of all, we have zeros at x equals 0 because of the x squared. And then we also have zeros at x equals 2 and x equals 3. So let's put some marks on the x-axis. That's 2, that's 3. That's where our zeros are. And you can start on the right or the left. We're going to start to the right of 3 and figure out whether or not the graph is up here or down here just by substituting a point. Well, if we figure out f of 4, we get 4 squared, 4 minus 2, 4 minus 3 cubed. That's 16 times 2 times 1. That's equal to 32, which is greater than 0. So the graph is up here somewhere. That's positive. If we were to put a scale on the y-axis, there would be a 32 here and a point here. Now, at x equals 3, notice the cubed. So this is the type of thing that happens. It's going to come down to the 0. And do this. Now at x equals 2, we have a first power. So it's going to do this. It's going to go right through the axes unimpeded. So guess what? It has to turn around and go through. You can see the inflection point there. And then now at 0, well, at 0 we have a square. You can think of this as, this factor here sometimes causes confusion. Think of that as x minus 0 squared. Gives you a 0, 0. 0 minus 0 is 0. Okay, now we have a square, so guess what? It does this. It just bounces off the axes. So we have to turn around and then do this. And we'll put an arrow on the end here because it continues either direction. And that's the basic shape of the graph. If you have a graphing calculator, you can adjust the window and graph it. It will look like this. If not, just Google polynomial function graphing utility or something like that. And you can put this into a window. It'll draw a nice graph for you. You'll see it looks exactly like that. So one thing to note, this is a square, a first power, a third power. 2 and 1 and 3 is 6. This is a sixth degree function. That's even. Even polynomials do the same thing on the extremes. If it goes up here, it goes up here. Had we started down here, it would have been down here. Odd degrees do the opposite. behavior on the end. Let's look at another example. Let's suppose we have f of x is negative 2x, x plus 2 squared, x minus 2 squared. And we're going to draw our coordinate system. And first of all, this gives us a 0 of 0, negative 2, and 2. You just have to think what makes that factor 0. What makes x 0? X equals 0. It's pretty simple. Negative 2 plus 2 is 0. 2 minus 2 is 0. So we have a 0 here, and then right here, and then right here. There's our 3 zeros. Now the question is, you can, again, I could plug in negative 3, figure out which side we're in, or plug in positive 3, figure out which side of the x-axis we're on. I'll just pick 3. Negative 2 times 3, 3 plus 2 squared, 3 minus 2 squared, negative 6 times 25 times 1. You can work this out, by the way, but see, we have a negative, so that's less than 0. So guess what? We're down here somewhere. We're down pretty far. That's negative 150. So we're down here. I'll just put a dot there to indicate where we are. Now let's start with 2. X minus 2 squared. I can erase my check marks here. Guess what? That's where we are. It's just going to bounce off the axes. I'll put my arrow there. Then we come to 0. That's this factor here. That's a single power. It's just going to go right through. So we have to turn around and go right through the axes. And then when we get to negative 2, that's a square, so we are right here. That's a square. So we have to turn around and it goes up. And notice we have opposite behavior. So I can cover up my polynomial opposite behavior. I know it's an odd degree. Well, we have first degree, second degree, second degree. This is a fifth degree polynomial that's odd, and we have this opposite behavior. It's just a good check. It's not that important of a principle, but it's a good check. Just add up the exponents and then make sure you have opposite behavior so you didn't mess up one of these zeros in the middle. So that's all for objective 1. You have a few homework problems that are no more difficult than this. And if you want to check your work, you can go online and Google polynomial grapher. Yeah, right there. It's just polynomial okay, something simple will come up at the top of the list. I'll leave that to you. There's lots of those utilities online.